All right, so what I want to do right now is I want to record some videos that show us using Desmos to answer the questions in the textbook on Extrema. What happens for local min and local max. So what I'm doing is I'm looking in the textbook at determine any local extrema and absolute extrema, and we're going to look at some of the problems in section 4.1 from 33 through 44. And what I want to look at first is I'm going to pick some of the even problems because I think I'll assign some of the odds as we go through. And so what I'm going to do is look at number 34, where it says we have this function g of x that equals 1/4 x. Now, what I want to identify as I'm doing this is I want to see that, hey, this function is linear. And so a linear function will not have any local mins or max, no extrema, and it won't have any no absolutes. Right? And we should be learning that lines do this, but we want to use our graphing software to show that for us. So no absolute min or max. So let's come over here to our graph. Let's see if my graph is still up. Yep. And let me pull up the browser here. And I'll make sure my lines are bold. And so what we want to do in Desmos is we want to make sure that we have a good window that we can see the graph. Usually from 10 to 10 is a good place to start. Now I want to type my function, so I'll type in g of x equals, and if I type in 1 and I use the slash, which is by the question mark, it automatically puts it into a division format. And so I can take that function, 1/4 of x, and I can write it in a way that puts my graph here. And now if I look at this and explore this, if I continue going off to the left-hand side, this will continue to get lower. And if I continue off to the right-hand side, this will continue to get higher. So there is no minimum or maximum that's local or even global, no absolute min or max. And so I'm able to observe this function using Desmos as my graphing calculator coming across. And so we get a way to observe the function. All right, let's look at another function coming from here. Let's look at number 36. And this is saying g of x should equal 1 minus x squared. Now, the patterns we should start seeing with functions, and I'm going to stress the pattern here, but we will use our graphing software to see it, is this is quadratic. And all of our quadratic functions had either a min or a max. In fact, this has a negative coefficient in front of the quadratic part, so it's going to have a maximum, an absolute maximum, and it's not going to have any minimum. And that absolute is going to be also what's local. So let's come back here and graph this. So I'm going to come over back into my graphing software here. And I'm just going to keep going down different lines here. So what I can do is I can click on this squiggly line bit here to hide that graph, and I can create another graph here. So I can create g of x equals 1 minus x. And if I hit Shift 6, it puts me up to do an exponent. And I have my graph here. And I can actually click on this, and it shows me that my maximum value is going to be 1. At x equals 0, the maximum of this function is 1. And so I can find my extrema, and I can look at it using Desmos to graph. All right, let's look at, I'm going to look for a function that isn't something we've seen before. So I'm going to look at number 42. So let me come down here and write 42. Oops. So 42, the function that I'm looking at, g of x, is equal to the negative absolute value plus 2. Now, when we studied the absolute value function, we said, hey, this thing is akin to the square root of x squared. And so it does pull in having a vertice. We might not remember this, but visually we should hope that we can see it here, that this is going to have a vertice. It has a negative in front of it, so it should flip upside down, and so we're going to have something that looks like this, with a maximum value at that point. So let's graph this and see if we can pull that value back out for us. So again, I'm going to jump over to Desmos. Whoops, that's not Desmos. That is where all the videos are going. Here we go, that's Desmos. I'm going to do the same thing. All right, make sure I'm going to remove my 1 minus x squared. And so I'm going to do negative. And the pipe symbol works for absolute value. It's a straight up and down line. It's usually above the enter key on the keyboard. And so I'll type that in, and it gives me the beginning and the back of it. And notice I have my maximum value here, and it's at 0, 2. So this has a local and absolute maximum of 2. All right, and let's look at the function for question number 43. And this will be the last one I look in this set, and then I'll record another small video looking at this in a little bit more detail. So let's go back to the blackboard here, and I'll write question 43 down. What we want to do is we want to look at the function of the cube root of x. Or we could think of this as x to the 1/3. This is saying the same thing. I tend to think of functions with rational exponents, and I tend to think of numbers as having the root sign, but these say the same thing. The rational exponent is the same as a cube root. So let's go back into our graph. Let me turn off that one. And so I'll say g of x is equal to x to the 1/3. And there we have our function. Well, notice if I look at this function, it's got this inflection point where it turns, but it keeps rising. And there's no place locally where it has a max or min. You can always get bigger going to the right, and you can always get smaller going to the left. And so this function has no local min and no local max. And what I want to do is I want to compare this function to the same thing with the root function. So I'll come down here and I will choose, notice we have a keyboard down here, and in it chooses functions. I'll choose the nth root. I'll make that the 3rd root of x. And notice I get the same thing. And so there we see the equivalence of those two formats. I'm saying that. And so I hope this will help you start getting used to Desmos. This will help out a lot for the functions that we do, especially as we're learning max and mins and different graphing.